So next we are going to try to decide. So again, this is the second video for 12.2. And hopefully you have this handout. We handed this out before spring break. We're trying to decide where the function is concave up or concave. Can you help me to change this downward? Sorry about that. So this time we don't have a graph. Without a graph, what we should do is take the second derivative. Second derivative, remember, if it's positive, it's like a smiley face, concave up. If it's negative, like a negative person have frowny face, etc. So the step one, say you need to find the second derivative and then set it equal to 0. The solution will be your boundary points. You're going to use those boundary points to set number line, table, and test points. If your second derivative come up positive, again, positive people is happy, have a concave up smiley face. If second derivative is negative, and again, negative people have frowny face, so you have a frowny face type of concave down. So we're going to do some example together. The first one, say f of x equal to 2x squared minus 3x plus 4, and they want to find the concavity if it has inflections points. So I need to take second derivative, right? So, but I have to start with the first one. So hopefully by now you're pretty good at taking derivative. So 2 times 2 is 4. And then x go down one exponent, so it's going to be first degree. Subtracting 3, the x is gone, this turned into 0, right? So that's the first derivative. But I need second derivative. Second derivative, just take this one more time. So that only equal to 4, right? So if it's equal to 4, it's a positive number. I cannot plug in any x in there to make it negative, right? So it's a positive number. So if the second derivative equal to positive, then it's going to be concave up, right? And then because I cannot plug in any number, so it's always going to be positive. No matter what number for x, which we don't have a place to plug in x, right? Therefore, it's going to be concave up from negative infinitive to positive infinitive. So that's the answer. And because it didn't change concavity, it's going to have no inflections point. But they didn't ask for inflections point for this one. Are we okay with that? Okay, anytime if it's going too fast or you need to write something down, please pause the videos. The second concept here is about inflections points. This is the point where the concavity change. So if you want to find inflections points without a graph, again, you're going to need to find the second derivative and find an x value when f taking second derivative will equal to 0 or the second derivative does not exist. We use those to make boundary points, and then after that you're going to use those boundary points to set number line, table, and test points. If you have a concavity change to the left and to the right of that point, then that is your inflections points. So just be careful after you find the x, and if you need to find the y value of that point, you should plug it to the original function. So that seems to be sometimes students plug it to the wrong functions. Okay, so we have 2 examples here, number 2 and number 3, and I probably need to get a piece of paper to do that. Can do this here. So again, we're going to try to find boundary point and inflections point, I guess. Not boundary point, concave up and concave down, and then the inflections point. Is that what we want? I think actually just finding inflections point. Okay, So let's look at number 2 if we need to find inflection points. Number 2, this is chapter 12.2, video 2. Second example, f of x equal to x to the 4 minus 6x cubed plus 2x plus 8. Alright, so again, if we want to find inflection point, we probably need to get the second derivative first, right? So if you want to go ahead and pause the video, see if you can find the second derivative. Okay, so I'm going to check with you now. F prime of x is going to be 4x cubed minus 6 times 3 is 18, x to the second plus a 2, and then that turns into 0, right? But I need one more time. Second derivative is 4 times 3 is 12, x 1 less power is 2, minus my 18 times 2 is 36, x go 1 less power, my 2 will turn into 0. Alright, very good. Alright, so don't forget to write down the notes, so when you come back I probably will check it for attendance. So after that they say if I'm trying to find the inflection point, we did the first step, found the second derivative, and then set the second derivative to 0, right? That will help us to get the boundary points, okay? So we have 12x squared minus 36x. So to solve that, what do you think? So hopefully you know we should factor it out. So they have something in common, which is 12x, okay? So after we put 12x, we still have x minus 3. So once you have factor times a factor equal to 0, you can do what? Okay, set each factor equal to 0 and solve, right? So 12x equal to 0 and x minus 3 equal to 0. So one of the point is x equal to 3. The other point is divide both sides by 12, so x equal to 0. So those two are your boundary points. So after you have the boundary points, use to set number line and table. So again, if anytime you need to pause the video, feel free to do it. But on the number line, make sure you put the smaller number first, because this is going to a negative infinitive and positive infinitive, right? So this is my 0, and this is my 3. So using that, I can set a table. And go ahead and fill out those interval notation and pick me a nice point that I can test if you want to, and stop the video. And when you come back, hopefully you know this is x equal to 0, this is x equal to 3, and then this is between negative infinitive to 0, 0 to 3, and 3 to infinitive. And a nice point we can do is test negative 1, x equal to 1, x equal to 4. And the question is, where do I plug it in? Because I want to see the inflection point, which is related to concavitive. So that's why we need to plug it into the second derivative. Negative 1. So we got 12 times negative 1 squared minus 36 negative 1. And go ahead and pause the video and see if you can find those numbers for me, and we can check together. So hopefully you know the first one is positive, so we say concave up. Second one is 12 minus 36 is going to end up with a negative number, concave down. And the last one, we got, what is that? That's a really big positive number. So if you do that, it should also be positive, right? So this is concave up again. So remember, this is x equal to 0 and x equal to 3. If you have concave up turn into concave down, then x equal to 0 is an inflection point. I mean, you need to find a y value, but you have one of them. And this is also another inflection point, right? So to find the y value, where do we plug it in? So hopefully you know it's going to be plugged into the f of x, original function, to get y. So x equal to 0, x equal to 3. We need to find f of 0, which is 0 to the 4 minus 6 times 0 to the third plus 2 times 0 plus 8. So all you get is 8. And the other point is f of 3. So 3 to the 4 minus 6 times 3 to the third plus 2 times 3 plus an 8. So hopefully you get negative 67. So which means the inflection points are, one is 0, 8, x equal to 0, y equal to 8, and then one is x equal to 3, and y equal to negative 67. Are we okay with that? So that's one of the questions. Let's just zoom out just a little bit. So if you cannot see the whole screen, sorry about that. You can pause it and catch up with the taking notes parts. So again, concavity, if you want to see concave up, concave down, you need second derivative. Positive is concave up, negative is concave down. If you need to find the inflection point, you still have to check out the concavity, and if they change from concave up to concave down or concave down to concave up, then you have an inflection point, which we have here. All right, let's move on to the third question.